If you're interested in adding payments into your application, in this tutorial and with this new open source repo, we're going to show you how to do that. So let's say you have an LLM-based chat application and you want to start charging for usage. One very common way to implement this is through a credit system that can track how many LLM requests users are allowed to make. So here we are in our chat application. I can go ahead and chat with our graph to message the LLM, which will deduct a credit from our account. And now we can easily go over to the pricing page, purchase a new Stripe subscription, which will give us more credits to chat with the LLM. Next, let's take a look at the infrastructure required to build a system like this. This codebase has 5 key areas. The first area of the codebase that I'd like to go over is the authentication layer, which includes a Supabase implementation that for user-specific functionality such as logging in and logging out. And we also utilize that Supabase token to protect our LangGraph agent through a middleware file. Next, we have our payments infrastructure, which is implemented in Stripe and allows users to purchase subscriptions to get more credits added to their account. We then have our credit infrastructure layer, which is also saved in our Supabase table and has a series of utility functions for adding, refreshing, and removing credits. We then have our chat agent, which is a ReAct LangGraph agent and also has a web search using Tably. Finally, we have our user interface, which is implemented in shadcn. Now let's dive into the code and we'll take a look at how each of these systems is implemented in greater detail. First off, this is a monorepo which has 2 applications within it. The first application is our agents repo that contains our LangGraph agent as well as a middleware file to protect our graph with auth. Then we have our web application which contains our user interface, our Stripe integration, our Supabase auth, and also our credits implementation. So getting started with our LangGraph middleware auth level, we're going to look at this auth.ts file in the security folder of the agents application. So this is our core LangGraph middleware file. It's critical to this repo, so I'm going to dive through it in detail. At the top of our auth file, we have a few utility functions to bind user-specific metadata to LangGraph events. And then getting into our main function here, this is where we're going to take all the incoming requests, check the auth headers, and make sure that the header includes a valid Supabase JWT token. If it does include a valid token, we'll be granting the user all these permissions to interact with our graph. So every time the user wants to interact with the graph, they'll call this file and they have to be granted the permissions in order to do so. Then at the bottom, we bind these particular permissions to the user metadata. The next file of our LangGraph authentication layer I want to point out is our LangGraph.json file. And this is a configuration file where you can see we added a property here to point to the auth file that we just looked at, which is how we're going to hook it into our backend. Now let's take a look at how the Supabase authentication layer of our application is implemented. Starting off with our authentication provider, this is a provider that's going to wrap our entire application and give us the ability to manage the state of the auth on the client side of our app. So most of this file is setting up the authentication provider and we implement it in another file. We have the interface here, which includes some utility functions for user-specific behavior, and then we are initializing the provider. Next, we have our Supabase utils file, and this is going to actually implement the provider that we just looked at. And in this file, we have a lot of the actual user-specific functionality and utility functions, such as signing up, signing in with an OAuth provider, and signing out. Now let's take a look at how the payments infrastructure in Stripe is implemented in the app. First off, we have our stripe.ts file in the lib folder of the web repo. And this is going to have a few of our utility functions for performing Stripe-specific events, such as creating a session, getting a user subscription, adding user credits through updating our user table in Supabase, or deducting a user's credits. Then one other key file on the Stripe implementation is our webhook route. And this is where we'll be listening and processing Stripe events as they come in. So you can see we have a switch statement here with multiple cases for different user events, such as a new subscription being created, updated, or deleted, and we'll appropriately update our user in the user table based on that. Now let's take a look at how we implemented the credits infrastructure in this app. So starting off, we'll take a look at our credits provider, and similar to our auth provider, this is going to wrap our entire application and allow us to track the state of credits throughout our app on the client side. So we have an interface here that describes the provider, and you can see we have a few utility functions here for key events such as refreshing, updating, adding, and removing credits. Then we have 2 files that actually implement this provider to perform these functionalities. So first we have our use credit deduction hook, and that's because we have 2 methods of updating credits. The first is to optimistically update the credits on the UI so the user can immediately see a response. And then the second thing we do is finalize that in the Supabase database. So we first hook into the UI and update that. And then in our Stripe file here in the lib directory, this is where we're going to actually have our user credits utility functions that will go into our Supabase database and update the user table accordingly. Now let's dive a little deeper into the actual chat agent and the user interface side of the application. And this is also going to connect back to the auth as well. So on the agent side, this is a ReAct agent. It's a LangGraph TypeScript agent that also has a web search using Tavily. And on the UI side, there's a few key files I want to bring up here. So yet another provider is the thread provider, and this is where we're going to pass information about the particular conversations we're having with the LLM through the application. And the main reason I want to bring up this file is because this is one of the key files where we're actually passing the Supabase JWT token through the application, so we can pass it to our LangGraph middleware and make sure the user is auth. So you can see down here, we have our JWT token. And when we create our LangGraph client, we're also passing in that JWT token so it can interact with the graph as well. Similar to the thread provider here, we also have a stream provider. And this is one other place in the application where we are passing the JWT token through. So you can see here in the stream, we're passing a header with our JWT token. And that way we can pass it through our application so our graph is able to interact with it. One other file that I'd like to mention as we're wrapping up here is in our documentation, we have this credit system file that has an outline of a lot of the key files that we just talked about, and not only the credit system, but also the authentication system. So if you're looking to dive a little bit deeper, you can go read this file. We also have a great README that has step-by-step everything you need to do to get this repo set up and running on your own computer, because the goal of this repo is for you to just be able to make a few different changes and have your own full stack application running. So I hope this video was helpful to help you do that. If you have any questions or comments, please feel free to leave a comment below and I'll respond. Thank you so much for watching this video, and I'll see you in the next one.